All right, so here we have that a manufacturer drills a hole through the center of a metal sphere of radius 5 inches, shown here, and the hole has a radius 3 inches. So what's the volume of the resulting metal ring? Okay, so this is sort of like, taking the volume of a sphere and subtracting the volume of a smaller sphere, except that it's cut off like at the at these endpoints, so it's not quite a full sphere. It's like a ring that you would kind of put on your finger, so there are openings through it. So let's look at it first at like a two-dimensional picture of what the area we would be looking at would be, and then it'll be easier to set up our integral. Okay, so we have essentially, see, if we have the inner ring is at a radius of 3 inches. So then this point up here, think of it as like a horizontal line, we'll think of it. But you're only really going to be looking at the area of like this top portion above 3 to the top of the outer surface of like the sphere thingy, ring thingy. So it would essentially be like something like this, so to speak. So we're going from 4 to -4. So that's 4. That'll be -4. And then that's 3 inches, 3 inches above the x-axis. This point will be at 4, 3. And this point will be at -4, 3. And then this top portion, is going to be kind of like the top part of a parabola going through those points. So we're looking at this area here. So this area here, we're rotating around the x-axis like so. So our axis of revolution is this x-axis here, going around it like that. Now, what we want to figure out is what what the outer radius and inner radius values or functions would be for those. So then we can just set up our integral as, remember this, pi times the integral from a to b of large R of x, the outer radius of x squared, minus the small r of x, the small radius squared. And then we integrate this. So we have to find a expression for large R of x and small r of x. So this one isn't too bad once you can see this. So again, remember, this is the axis of revolution. So large R of x would be, the distance from here to the outer edge of this parabola. So this edge, that'll be our large R of x. And that's simply just going to be the equation of this. Now, so before we get to that, let's now look at the small radius. Small radius is just going to be from the axis of revolution, the x-axis, to here. This horizontal line is just the line y equals 3. So small r of x is just equal to 3. This is always the same. So small r of x is equal to 3. Now, large R of x, we just have to find the equation of essentially a circle that would go through these points here. Now, this circle we're told has a radius, or you're not the circle, but you're told the metal sphere has a radius of 5 inches. So up here, that would be at the point, it would reach a peak at 0.5. And then you basically just solve for the equation of this in terms of x. So we want to have a function of x. So then, if you remember what this would be, it's a circle of radius 5, centered at the origin. So think of it as just, x squared plus y squared equals 25. Remember, that's a circle centered at 0, 0 with the radius of 5. And if we were to expand this, it would be a huge circle there. So then we just solve for y. Take away x squared, you get y squared equals 25 minus x squared. Square root it, and then large r of x, large r of x would be y being equal to the square root of 25 minus x squared. So large r of x would be the square root of 25 minus x squared. All right, now we can set up our integral. So rewriting this, the volume is equal to pi times the integral. We're going to go from -4 to 4 of large r of x squared. So this squared just undoes the square root sign. So then we just have 25 minus x squared minus small r of x squared. R of x is 3, so 3 squared would just be 9. Dx. So we just have to solve this integral. So we get pi times the integral from -4 to 4. 25 minus x squared minus 9, so it'll just be 16 minus x squared dx. Okay, and then this is not a problem. We go integrate this, antiderivative, we get pi times 16x minus x cubed over 3 from -4 to 4. We get pi times 48 minus 4 times 4, 16, 16 times 4, 48 over 3, minus, throwing out -4, that'll be -48 here. -4 squared, that'll be -48 over 3, so minus -48 over 3, we can just say plus 48 over 3. Oops. Let's go to this next line here. I'm going to use my pen. So we'll get pi times and I just realized this is not 48. 4 times 16 is 64, of course. I want to see if you guys were going to catch that. That was part of my strategy, to see if you guys feel confident in your algebra skills. So that was intentional. Okay, so then we have 64 minus 48 over 3. And yeah, you guessed it. This 48 is also 64 over 3. Yep. That was also cleverly disguised. And yep, this 48 is also 64 over 3. Not a problem. I got this pencil with an eraser. Good as new. All right, so we just go ahead and keep on working this out. These look like they're minus -64 over 3 minus that. So then, yeah, we're gonna have some work to do, looks like. We're gonna have a 128 minus negative minus a 128 minus 64 over 3 minus a negative 64, or minus 64 over 3 here. So minus 128 over 3. Multiplying that by 3, 328, 256. 56, 284, 384, I believe. Not a worries. So 3 times 128. Yeah, 384, of course. So pi times 384 minus 128. All over 3. So we get 256 over 3 times pi. And there you go. There's your answer. Not a problem. All right, so I hope that helps. Good luck, folks.